Hello everyone, my name is Justin and this is my channel American Pie. Today we're going to look at Leetcode number 1006, Clumsy Factorial. The question is as follows. The factorial of a positive integer n is the product of all positive integers less than or equal to n. For example, the factorial of 10 is 10 times 9 times 8 times 7 times 6 times 5, etc. So, it seems pretty straightforward. It's just a descending -1 all the way until we hit 0, multiplied all together. But to make a clumsy factorial, instead of following this pattern, we follow a different pattern. So the clumsy factorial of 10 is 10 times 9 divided by 8 plus 7 minus 6 times 5 divided by 4 plus 3 minus 2 times 1. Essentially, it's a pattern of times divide plus minus, it looks like. Now, on to the main question. It says, given an integer n, return the clumsy factorial of n. So when we do this, we're going to need to follow the order of operations. When we look at these examples, we have n equals 4, the output is 7, and that's because 4 times 3 divided by 2 plus 1 equals 7. So I'm going to make note of that. Okay, so on to the main code. If a factorial's formula is factorial of n equals n times n minus 1 times n minus 2 times n minus 3, etc., then the clumsy n formula is going to be something like what I show on line 5, where it's going to be divide by n minus 2 plus n minus 3, etc. And if we look at this, it's pretty clear that there's probably going to be some mathematical cancellation when this is actually applied, because n plus 1 is going to divide into itself. I'm just not quite sure what it will look like, but this leads me to believe that it's going to be a dynamic programming style solution. So the first thing I'm going to do is just map what every single possible target is. So I've gone ahead and mapped out the target values to their corresponding return values. 3 maps to 6, 4 maps to 7, etc. Generally, with dynamic programming problems, they either build on top of each other's return values, or they build on top of an existing value like the parameter you were passed. In this case, I'm going to see if there is a pattern in the parameter being passed, which is n, and the return value. So with 10 as the target, the return value is 12. That's n plus 2. 9 as the target is also n plus 2. 8 is n plus 1. But 7, interestingly, is n minus 1. Finally, if we keep going down all the way to something like 3, we can see that it doesn't follow this pattern at all. Why don't we just continue looking at the target to return value mappings and see if this has any pattern. Okay, I just about finished mapping. I've mapped 11, 12, 13, 14, 15, and as you can see, it follows -1, +1, +2, +2. If this pattern repeats in sets of 4, which is expected because we're doing 4 operations of plus, minus, times, divide, then the next one is going to be n minus 1. So this pattern, interestingly, is followed, but it's only followed after the first 4 numbers. Because of that, I think when we code this, we're going to have to cover the edge cases of the first 4 numbers right at the start. Since we've established that this pattern we see is in groups of 4, we're going to have to do a modulus 4 operation on whatever the target value is. And then we have to map it to its corresponding pattern that we see. So for divisible by 4 elements, we can see that the return value is n plus 1. But for elements with a remainder of 1, the return value is n plus 2. With a remainder of 2, the return value is still n plus 2. And finally, with a value of 3, the return value is n minus 1. With this pattern established, we still have to handle the first 4 elements which don't seem to follow this pattern at all. In the case that our value is 1, we can return 1. If the value is 2, we can return 2. If the value is 3, we can return 6. And if the value is 4, we can return 7. After we get all these done, the remaining values are just going to be a simple if statement. So as we established in our comments above, for when there is no remainder, we know that we return n plus 1. If there is a remainder of less than or equal to 2, then our return value is n plus 2. And if it's neither of those, our return value has to be n minus 1. Let's go ahead and run this code and see if it passes our test cases. Yes, it does. So we should be good to submit. Looks like we beat 100% at 0 milliseconds.